Hello everyone and welcome back to another Universe Sandbox video, and welcome to the distant past of the solar system. 4.6 billion years ago, we are in the solar system's formation period here. So we can see the sun directly in the middle, obviously the accretion disk around here where planets are formed. But today, we're going to be doing another alternate reality version of the solar system. And if you saw the recent one we did, I wasn't most happy with the outcome. So I want to have another shot at it and try forming the solar system to give us some better results really with the orbits, because we had a lot of stuff ejected and it was quite a big mess by the end. It was still interesting, but I want to try and get a better result, and I want to try some different things with the planets we know and love here and see kind of what sort of alternate reality we can come up with. So what I wanted to do, and this was the biggest thing, I want to have Neptune as the dominant gas giant in this system. So not Jupiter, not Saturn, Neptune. I want Neptune to have the massive Jupiter in this system. And the other gas giants will kind of be in reverse order. So we'll have Neptune and Uranus as the Jupiter and Saturn and Jupiter as the smaller gas giants in this system. So the ice giants will be the bigger monsters of the group. So what I'm going to do is, also we're in the young system here, we're going to kick it off with Neptune. So where do we form Neptune is the question. So I'm going to plop it. I'm going to still keep it roughly in the area that it would have naturally formed. So I'm not going to have it ultra close. Let's say that the biggest planet forms further out in this scenario. So let's go ahead and plop Neptune at, I'm going to say about 12 AU. I'm going to plop it there. Roughly ish where it may have formed. Who knows, right? So there we go. So the Neptune is the dominant gas giant. I'm going to plop Uranus a little further out. I'm going to plop it around, do we go 18? That's roughly in its present day area, isn't it? Let's have Uranus as the further out. We're going to plop it at 20. And there are our two dominant worlds in here. So there it is. We've got the young Neptune over here. Take a bit of time for it to warm up in this field here. If we speed up time a bit, we should see it warm up a bit with the background simulation temperature. But what I'm going to do is, Neptune, I want you to have the massive Jupiter. Neptune is the proper, full-on dominant gas giant in this system. So there it is there. You'll see very dark. Radius-wise, it's almost the size of Jupiter as well. So there you go. So the dominant Neptune. We've got Uranus. Over here, so let's see if we can actually lock onto Uranus. Uranus, can we get onto him? There it is. So Uranus, I'm not going to have you on the level of Jupiter mass. We're going to double it up though. We're going to put a 0.366 Uranus. So still a decent presence in the outer solar system there. Not as yeah, I mean if we look at Earth's 116 Earth mass, which is actually more than Saturn has normally. So again, this could be pretty interesting. So we've got two dominant gas giants that have formed. Let's go ahead and speed up time. Just let the... obviously, the biggest stuff normally forms first. There you go. So Neptune and Uranus are in there. There you go. So now they're hot. Yeah, now they're forming. So nice and warm in the young system. So now, we've got the first few objects formed, of course. So now, you can see their orbits hidden in there. Now we need the other planets. So, Jupiter and Saturn. They're our next two worlds to form. So Jupiter. We're going to plot that around. Let's say, we'll put it roughly where it would normally be in the present day. I'm going to plop it around 5 AU. I'm going to put it there. And then Saturn, we're going to have... Does Saturn go before or after Neptune? Is the question. I'm going to plop it in between Saturn or Jupiter and Neptune for now. And there we go. What I need to do is, before we even run the simulation, Jupiter is not going to have the mass it normally has. I'm going to pull it down to, let's see here, 79. I'm going to pull it to, so it still has a decent presence. 34. That's more than Neptune and Uranus would normally have. Saturn. Again, same deal with you. This only normally has 0.2 Jupiters, so that's about 59 Earths, isn't it? Yeah. Or 95 Earths, sorry. Where did I get that from? Anyway, so, same with you. I'm going to have you lower. Still larger than Neptune and Uranus normally. I'm going to put it at 20 Earth masses. Saturn would normally have, obviously, a lot more. But still more than Neptune's 17 and Uranus's 14.5, I think it is. So, there we go. So we've got our four gas giants formed. And there you go. And then again, for a bit of laughs, we'll throw in the fifth giant. Do we use the Planet 9 template or do we use the fifth giant template, which I have somewhere? Let's see. Which one should I use? I think we used the fifth giant one last time. Let's see. Fifth. Yeah, the fifth giant's there. Or do I use the good old Planet 9 version, which is there? We'll go the Planet 9 version this time. Let's plop that in between Neptune and Uranus. So let's plop it there. There we go. There's it, Planet 9. But again, it will be renamed to the fifth giant for this scenario. There you go. This we'll keep it as 5 Earth masses. We'll duff it. And I'm gonna put a little higher. I'm gonna put it to 10, like it originally had in this theory for the Planet 9 theory. Anyway, so there we go. The 5th giant is in here as well. So we've got our 5 gas giants, each with different masses. So it's a bit of a mystery how the 5th giant's formed. You know what? Actually, no. Because Neptune and Uranus have got all the mass in that region, technically the 5th giant will be further out than that. So I'm going to move its period further out. I'm going to plop it beyond the orbit of Uranus as the final gas giant in the solar system here. There you go. So there's our gas giants. Now the terrestrial planets. So if we move in here, obviously Jupiter nowhere near has the mass that it would normally have. So that means that Ceres and Mars, for instance, would again, in this scenario, become larger than they are in the present day. So let's see how that would unfold here. So let's go ahead and just slow down time, just so things are moving a little slower. I love the particles in these as well. I mean, if we turn the goggles off, they're nowhere near as exciting. But for just so we can see what we're doing, we'll go ahead and do that. So let's have the young Mars form first. I'm going to plop it roughly. We'll put it at 2 AU here. It's formed a little further out in this scenario. Ceres as well. We're going to plop that a little further away than Mars. So we're going to put it around maybe the 3 AU mark there. There's Ceres. Slightly different orbital tilt I did on him as well. So if I can select Ceres, that'd be lovely. So again, this is going to be a full-size planet this time. So we're going to buff that up. Not going to be the largest thing out there. I'm going to maybe put 0.1 Earths. Let's see how. So 0.6 Earths in radius. That's not bad. So again, Ceres is big enough here to become a proper official planet. So in theory, maybe its surface would be different. But what I'm going to do is I'm going to add more material to it as well. And maybe another elevation map. So let's go ahead and give it maybe a mix of. Let's go. Who should we go with? Mercury. Let's do a Ceres Mercury hybrid mix because that will mean it will get a bit of craters and a bit of action in there. So it makes Ceres a little more different. There we go. I'm also going to obviously give it. Go to composition here. I'm thinking about the composition as well. We're going to give these guys proper builds. So obviously I want to give it a bit of water. So I'm going to go ahead and increase the water stat. Give it some nitrogen. Give it some ammonia. There you go. Just a nice mix of it. Bit of carbon dioxide in there as well. Help them out. Oxygen. Yes, we want that. Let's go ahead and put that on as well. There we are. Let's go. There we go. So a nice big mix of different materials kind of slung in the Ceres there. So we'll see how Ceres does in the future. We'll give it some iron as well. Why not? A bit of iron. So nice big mix of material in Ceres. A lot different than it normally have. So already looking very nice. Mars, same deal with you. Mars is going to have a different look to its normal appearance. We can select Mars. That would be great. It's the only thing with these ring particles. They're a bit mischievous to get through. So there we go. So here's our young system so far. Mars, that's who we want. Already looking pretty cool, actually. There we go. It's already built an atmosphere of some kind. What's going on here? Looks awesome. The one thing we need to do as well is these worlds are all bigger than normal. They are going to get magnetic fields. Let's go ahead and do it. The same with Ceres. I'm going to switch it on. I'm going to give it a magnetic field. There we go. Just give it a nice big. Just give it something. We'll have to go ahead and adjust these manually anyway. But let's just quickly come out of that again. I want to make sure it is working. Let's go to Ceres. Looking good here. Right. We need to see that magnetic. There you go. So Ceres is going to have some protection. Looking good. So again, back to Mars. We want Mars to obviously have a magnetic field at this point. And because Mars is going to be a full-size planet in this scenario, it's going to retain that magnetic field into the future. So here we go. There's a young Mars looking very, very nice. So let's go ahead and, again, buff it up. We want to see that magnetic field. There you go, Mars. A nice bit of protection. A nice big one. There you go. Let's give it its proper size as well. So Mars' normal mass obviously is here. I'm going to go ahead and double this. And then double it again. And then I'm going to double it again. So 0.8 Earth. So Mars is a much larger world than normal. It's one radius of Earth perfectly as well. Just by natural chance there. So Mars is going to be a much nicer place in this system. Hopefully. If fate allows it to go. So I'm going to go Mars. I'm going to combine it with the Pluto texture. That should make an interesting dynamic here. So there we go. Looking good. So the young Mars. Earth similarity stat. Look at that already. Looking way nicer. Composition. We're going to go ahead and again throw in a lot more material than it would normally have. So let's go to Earth masses here. So, for instance, water. I'm going to throw in a bit of all these atmosphere masses. I'm going to go to Mars atmosphere masses. So, again, I'm going to throw in a nice bit of water in there. Carbon dioxide. Again, we'll throw in a bit of that. You know, just give it some stuff. Oxygen. Again, Mars is going to have that oxygen early on. I'm going to plop some of that in there as well. Let's see what else. A bit of ammonia, maybe we'll throw in a bit. No, just it's got to have just a random mix of material in there, just to give it a little extra heat and throw a bit of methane on it. There you go. So yeah, again, a nicer mix of material than Mars normally would have had. So that young Mars, it's going to hopefully become a nice look at the volcanoes. Actually, look at that. It's actually glowing at the moment. That's pretty cool. So the young Mars got its magnetic field going there as well. Very nice. There you go. So back to the sun. Again, the next 3 planets. So we're going to have the young Earth form next. So let's go ahead and put the Earth roughly in its normal position around the 1 AU point. This is 0.997 in this scenario. There it is. So the young Earth. Obviously, it's not going to have the constants we know and love at this point. But other than that, I'm going to keep Earth roughly in its normal area. If I could select the Earth, that'd be great. Nope. So there you go. So you can really see here, stuff's looking pretty cool. So the young Earth. So obviously it's not going to have the constants we know at this point. So I'm going to turn off that Earth elevation map. And we're going to give it a, to start off with, we'll give it a Callisto texture. There you go. So that will obviously change things up a bit. The rest of the material composition I'm going to leave alone. So Earth will have to sort itself out as time goes on. It already has its magnetic field that we know, so that should be fine. Yeah, it does. So that's good. Okay. I'll keep the magnetic fields on for the rocky planets only. The other gas giants we know, they already have them, so that's fine. So there you go. The young Earth is in there. But, obviously, we're going to go with the Theia theory. We're going to have Theia in here as well. So, let's go ahead and we'll build it off a Mars, for instance. We're going to have the Theia object quite close to the Earth's point. So I'm going to put it in a similar position there. Roughly in that 0.9 AU region there. Also, we're going to rename it to Theia, if I can select it again. So it's the alternate Mars we need to go to. So down here. So already, I'm putting a lot more thought into this than the previous scenario we did. So I'm hoping that this will hopefully give us better results. So here we go. So this is obviously Theia. It's a Mars-sized world. I'm going to make it a little smaller than the regular Mars, the Mars we know and love. So a little smaller. Still enough for a planetary, to be a planet. But nowhere near the size of Earth. There it is. Surface texture. I'm going to put it to, let's go with the Sedna texture. Why not? We'll go Sedna and Io. Interesting. There you go. Let's plop them together. There you go. The visuals. Atmosphere and stuff doesn't matter. The where are we? The base colour is going to be. Oh no! Out! No. So base colour, elevation. I want that to be custom. There we go. And there's a mix of different colours in there. I mean, it looks like it's not going to let us do it, but there we go. So it's just a white world. The young Theia is in there. Again, moving on a little closer to the sun. Obviously, we've got to have a young Venus as well. So let's plop in the Venus, as we know and love, around 0.7 AU there. Roughly in its normal period. Again, and I'll throw in Mercury as well, because we're going to get to that. But I'm going to put Mercury in a similar region to the Venus Theia orbit. So I'm going to pop it actually a little past Venus. Because again, the theory always was that Mercury didn't form where it was. It's been moved there. So I'm going to plop it a little closer. So there's quite a bit of... There's quite a little... It's going to be a bit of a punch-up in the inner system of a lot of bodies around here. It's going to be the survival of the fittest. So the young Venus here, obviously it's not going to have that atmosphere yet because it's still in its very young days. So I'm going to go ahead and go straight to the atmosphere here, and we're going to remove that completely. And all those horrible gases. Let's go ahead and head here. Now, carbon dioxide, let's go to, there we go. I'm going to lower that. I'm going to literally halve it twice. The sulfur dioxide, I'm going to completely just eradicate how much that would normally have. So where are we? Is that normally in... where are we? I'm going to just lower that down a bit. Kilograms. Still has a lot, isn't it? There you go. So I'm going to really lower that down. There's way less of that than normal. Water, I'm going to re-add to Venus. So let's go to... Here we go. So we've got water. Nitrogen. Again, double a bit of that. Carbon dioxide we're going to leave there. Still going to have a bit of that. There we go. So again, Venus. Whole different place here. Then down to the atmosphere stats. I'm going to remove that atmosphere completely to start off with. We're going to go ahead and give it something a little more retainable. So it's going to go to 0.8 AU. So there we go. Or ATM, sorry. So that will give Venus a much better chance in its early days here. And then the surface map. We're going to combine it with maybe the... Let's go with... Who should we go with? I'm going to think maybe the Pluto one. Just a different mix of craters and stuff on its surface. Should be quite an interesting duo, actually. Venus and Pluto combined. Should be pretty cool. Okay. And then lastly, Mercury. Again, similar thing for you. I'm going to double Mercury's radius here. Make it into a more full-size planet. It's actually larger than the Ceres planet is here. So we've got a much more interesting mix. And again, Mercury having that extra mass and stuff, hopefully will allow Mercury to, in theory, get a nicer combination. Let's go Mercury and Ganymede. Actually, that'd be a cool duo. Should be interesting. Yeah, there you are. And again, yeah, this should allow Mercury to hopefully have a different fate. We will see. In the last scenario, it was the last rocky planet surviving. So let's see how it does in this scenario. Carbon dioxide, again, we'll give it a bit of that. We will see if it will be able to survive. So again, I'm going to give it some sort of randomised stats. Just nothing really, I'm not really thinking too much about these. I'm just plopping them on. So let's go 0. Blah, blah. Oops. So again, just random stats in there, just a bit of everything, and we'll see how the planet forms. Ideally, so that will hopefully give it an atmosphere as well. We'll see. There you go. So Earth is still the largest planet in this scenario, but we also have Mars and Venus of similar sizes. So no super Earth in this scenario. Everything's just regular Earth-sized worlds. I still can't believe the Mars formed at exactly the size of Earth. We've got 3 sister planets in very similar sizes here. And there you go. Well, yeah, one last thing we need to do as well is I'm going to give Mercury that protection as well. We're going to go ahead and give it a magnetic field. Let's plop it on. Oh yeah, Mercury already has one, doesn't it? Here we go. Let's increase it. Again, Ceres. I gave you one. Theia. If you sat... Yeah, we'll give Theia one as well. Yep, let's switch it on. Should see it come out. There it is. Theia's got one. Venus. Yeah, we're going to get all the rocky planets are going to have magnetic fields in this scenario. We're going to start them off. So they all have a fighting chance here. Should be interesting. So everyone's got a nice magnetic field. Very cool. There you go. So this... I'm not going to bother with the Vulcan planet this time because that one is even more hypothetical than the Theia is. I'm going to stick with these as my planets. So this is our lineup here. Oh. Let's just run the simulation a bit, get everyone going. So there you go. And then one last thing I need to do as well, actually back to Venus and Mercury, is I need to fix their rotations. And same with Uranus. Uranus is nowhere near as big as I thought he would be. Kind of want to increase that. So we are paused, aren't we? I don't want it being that big, but I want Uranus to have a a bigger size for sure. It's all the density, isn't it? So let's go ahead and I wanted Uranus. I wanted you around 0.3 Jupiters, didn't I? So we'll plop yeah, about there. About that. And it's the density, so I want to make this bigger. That's more like it. I want it to be a bigger planet. Not as big as Neptune, though. Then Jupiter and Saturn, in theory, these guys need to be smaller. Even though they've... well, it doesn't matter necessarily, because the mass isn't really... As long as the mass is fine, it doesn't really matter. So the gas giants are all similar size as well. The 5th giant's substantially smaller because it has got less mass. Saturn and Jupiter, though... So I want Saturn to be about 20 Earths, don't I? So again, let's get back to 20. I'm going to lock the radius there. We'll lock the density, doesn't really matter there. Jupiter as well. How large is Jupiter? So it's only 0.7. So yeah, all the gas giants are in similar sizes. This one's a little bigger, Uranus. But yeah, one thing I see, actually back to what I was doing, Uranus is not on its side. It has not had a collision in this system. So Uranus is going to be on its normal tilt. Making things a little more interesting. There you go. Same with Neptune. I'm going to have you on a more regular axis. Saturn as well. I'm going to have you slightly different. Maybe Jupiter is a little more tilted in this scenario as well. Down to the rocky planets as well. So Venus and Mars. Where are I? So Venus, your rotation. We're going to rotate Venus all the way around. It's not going to be upside down in this scenario. Rotational period is going to be more generic. I'm going to put it at 0.9 days, a little faster. Mercury, I'm going to lower this down as well. This is going to be the faster than 0.8 days. Ceres, we're going to increase the day to 1.5. And then the Theia. Down here, this will have the longer of the rotations. I'm going to put it to 2 days. There we go. Jupiter, no longer being the largest planet, I'm going to double its rotational period. Saturn as well, I'm going to double yours. Uranus and Neptune, no, I'm going to lower a bit. They are the bigger worlds. There we go. See how that plays out. And there you go. So that is my alternate reality system 2.0. I'm hoping that this will give us some better results here. So that's all of the major worlds in there. So there we go. The alternate reality. And then the one last thing we need to do is the dwarf planets. We're still going to keep the dwarf planets we know and love. I'm going to plop them all in past the orbit of the 5th giant, roughly. Around 26.7 AU. I'm going to start their positions over here. So we're going to go Pluto. I'm going to put them all in similar regions to start off with as well, in that ice area. Iris, Makemake, Far Out, Sedna. I'm going to pop that in as well. There we go. And also, Triton, being a dwarf planet, it's going to be in there. There you go. Any other ones I missed? Let's go ahead and just put in the other worlds. So, Maya, for instance. Let's plop that in. Nice. That's cool. Okay. Palace Investor. You know what? I'm gonna bring those into the frame as well. I'm gonna put mostly similar region to Ceres. I'm not gonna do too much to them, but I am going to increase their sizes. But they're gonna be, they're gonna be dwarf planets in this, rather than like technically asteroids. So we're gonna make them into something a little more interesting. There's the young Triton, looking cool. So where are I? Palace. I make it into a much more significant size. Vesta as well, bigger. Making Vesta, actually, we're going to make Vesta one of the largest dwarf planets out there. Almost as large as Triton. So again, this should give us some interesting results. So some of the major names of dwarf planets, I haven't put the whole lot in there, but we'd be here all day if we were doing that. So got the dwarf planets in there, looking good. So with all that, we have Charico in there as well. Why not? Let's plop that in there. Let's pop that. Oh yeah, that one and no, never mind. I'm not going to bother with that one. So yes, that is it. So again, let's go with another save, and that is my alternate reality solar system 2.0. But now it all depends. How will the orbits change? That Saturn-Neptune region could be a bit dicey. I'm going to lower Saturn a bit, just so it's in a decent position. I'm going to plop it roughly in the perfect spot between Jupiter and Neptune. Neptune, I'm going to expand it just a little bit. There's a little more breathing gap, so I'm hoping that this will give us better results. I haven't made things too drastic. It's just that inner solar system could be a bit interesting. So let's go ahead and press play. And there you go. So the young solar system is a go. Looking very good. So I'm going to remove the disk. And there you go. So there is our lineup of the young worlds. Looking good. At least I fixed Pluto's name. That's always the way I categorised it. There you go. I mean, technically everyone's name is a bit messed up, but we can get to those when we get to it. So yeah, right, looking good. Then we can get to customizing stuff once everything all cools down as well. So Neptune is the dominant world here, so that is the one to watch out for. The fifth giant in that dwarf planet region there could be capturing some moons, kind of like Neptune and Triton in this scenario. So again, should be interesting. But yeah, without further ado now, we need to go ahead and cool the system down and see how everyone formed. And also the inner system, this is where the trouble could be. There's a lot of worlds in there flying around. Look at the young Ceres already. Look at that. It's built an atmosphere by the looks of things. So now we need to go ahead and obviously cool down the background temperature back to its normal cooler looks. There we go. So everyone's going to cool down and we're going to see how things transform. So obviously the young sun is not as bright as it normally is. So things are a little cold. So Ceres, for instance, is too far from the sun at the moment to retain its temperature. But we can see it has a nice atmosphere it's built. Look at the Ceres. It's all frozen up. But it's waiting for later. There you go. So the young Ceres. Already a good start. So there we go. That is our system. So there we go. Let's go ahead and obviously go back to the normal system layout now. So there you go. Okay. So this is where it all begins. This is where we could see some changes. So the young Mars. How's the young Mars doing? Obviously very cold. But it has an atmosphere. And it's got its brilliant magnetic field to help it out in this scenario. So when the sun warms up a bit, that should hopefully be good news. There is Theia. Not much going on at Theia at the moment, but it has got an atmosphere as well. Venus. So it's looking like it's got its very thick atmosphere at the moment. That's just because we didn't customise it, so we can obviously lower that down and see underneath. Let's turn off that haze as well. There you go. Just go to, yeah. So Venus has got its normal colour. But we're going to go ahead and obviously give it a more nicer looking colour. And the same with that surface texture underneath. That shouldn't be a scorched wreck at the moment. So we're going to go ahead and put it to elevation. Put it on custom. So we can choose the colours of the young Venus. So I'm going to make it a little more friendly looking. More icy, greyish world. There you go. So the young Venus. The young Mercury as well. Also a world that could be hopefully turn into be a nice looking planet. But we do need to just have a look at its it's got its atmosphere there. Yeah, it has a blue atmosphere. There you go. Look at that. Clouds, we can enable those. Why not? The young Mercury looking pretty nice. We can look at the water and customization again once everything's just once we've got a more settled system, because we do need to run this simulation first. The young Earth again, looking nice. Obviously, it wouldn't have got water this quickly in this scenario, but just for sake of time, we're going to ignore that fact. So here we go. And let's just go ahead and don't know why it doesn't remember the simulation name. That's a bit weird. But there we go. So I fixed mostly everybody's name. And here we are. So Jupiter, Saturn, Neptune, Uranus. I mean, technically, I think we did... Neptune was in theory thought to have formed closer to the Sun than Uranus anyway, so this scenario may work. But Neptune is a dominant gas giant in here. Could that cause some different problems with Saturn and Uranus, maybe the two here? Or will the system remain stable? That is the question. We can see there's a bit of wobble already. But maybe Neptune being a little further out could cause some... you can see Saturn's orbit is already being tangled a bit. If we just highlight Saturn a bit more, let's just increase the yellow on it. We can see that yellow... That orbit is no longer circular. Neptune looks like it's been pulled on it a bit. That could cause some interesting action here. How's the inner system doing? So Earth and Theia still in very similar positions. Earth is actually a little cool at the moment. Not warm enough from the Sun just yet. Mercury, minus 14. Venus, minus 185. I think it's that reflectivity. We need to change that albedo for now, because it doesn't have its normal atmosphere stats, so it doesn't necessarily need that albedo. So we're going to go ahead and lower that down. Venus is going to absorb more light than normal. It would. So that should hopefully warm it up a bit, because it is the closest planet to the Sun. Theia. There's Mars. It's Mars at 2.85 years. A little further than normal Mars is, but it did pick up more of that material. So yeah, formed a bit differently. This has turned out to be an interesting one so far. So let's go ahead and now speed up time a bit. We need to really evolve this system. I want to see some action. So here we go. Then we can start evolving the Sun as well. We want to evolve the system from birth to death as well. So look at Saturn's orbit in there, just hanging around in there. And a whole different scenario. But I'll be very surprised if I somehow made this stable. If there's, if nothing gets ejected, I will be shocked. There should be some sort of action at some point with something being thrown out. We just need it. Just given enough time, anything can happen. So Saturn's orbit's just kind of being tagged on there, but Neptune's a little further away than orbit. Because that Saturn orbit is definitely the. If Jupiter's in the right place, that could cause some issues. But remember, Jupiter is not so powerful in this scenario. Fifth giant out there, not causing too much turmoil with the dwarf planets yet either. They're still sitting in there fairly nicely. That Saturn orbit is the one I'm more concerned about, though. Very interesting so far that this is actually remaining in a good, this. Look at it. This has been built pretty well. Good build quality on this. Let's see how long we can get. Oh, there you go. That's a dwarf planet. What is that? That was far out. That has now been pushed into the orbit of Neptune there. We can see it's Sedna's orbit, the red one, near Uranus. Oh dear. So we can start to see some of those dwarf planets. The fifth giant has obviously sent them in a bit. And they're being picked up by the larger planets. Oh dear. Uranus, how are we doing over here? Much more bigger and powerful than normal. And obviously Uranus also on its regular... It's on the side, isn't it? So maybe Uranus. Now we're calmed down a bit. Maybe it has a little more cloud formation than normal. So maybe we're going to double it up a bit. A little more action with the clouds. Maybe a little more colourful than normal as well. Let's go ahead and give Uranus a slightly different change appearance. Because Uranus is obviously the one that's on its side, very bland. So Uranus can have a little more cloud action. So we're going to increase the colours on it. Just to show it's a little more not so bland as it once was. There we go. Ahead and give it a bit more, increase the mix of colour on Uranus a bit. Just increase those colours. There you go. So a little more of a changed ice giant than it normally would be. It's a little more action going on. Not as colour enhanced as say the Neptune is, but it's got a better chance than normal. They would never had that impact knocking on its side and spoiling everything. So a little more cloud activity from the young Uranus here. Some of those colours may be a little too intense, but it still shows it off a bit more, doesn't it? So there you go, the young Uranus. There's a little more cloud formation on him, isn't there? So there you go, a little more bluer than normal. There you go. Nice. Let's just go and get a lineup of everybody as well. Let's see our current lineup. So the gas giants here are in radius. So again, it's an interesting mix of Jupiter, despite having less mass than Uranus, is still larger. Saturn is actually the smaller of the main four. Got the fifth giant there being substantially smaller. Mars, Earth, Theia, Mercury, Ceres with its nice atmosphere. There's Theia. So a very, very interesting mix so far. But that inner solar system, there's no way that Earth and Theia are going to keep going like that. There's going to be a change at some point. There's got to be. And even Mercury and Venus, I'm surprised that they are holding on still. Looking good. Oh yeah, you can see there's some Neptune is definitely got some twists in there, isn't it? Oh yeah. Earth and far out. Could be some changes. I think yeah, the Earth orbit and the far out orbit with Neptune, they're definitely where the action is at the moment, I reckon. Look at that Neptune there, just slinging poor old far out around. Oh, Sedna. There you go, Sedna starting to do what it does in its normal. Oh yeah. Sedna could be in trouble. That Neptune, a slingshot, could be pretty deadly. So Sedna being the furthest of the dwarf planet orbits now. So that orbit could expand there. Pretty dangerous business for Sedna. So there we go. Let's go ahead and just pause. Going for another save before we go for the first of the evolutions now. So there we go. So this one's just called alternate reality. It's replaced the one we have. Now the sun. We're going to immediately start evolving the sun back to its normal day. So we're going to go see increase the luminosity. I'm going to put it to 0.85 suns, making it brighter. Not on its normal level, but no, we're getting there. So hopefully it'll give the rocky planets a bit more of a kick to pull their socks up and start actually warming up. So Mercury, the first of the worlds, in the positive temperatures there. Venus, what about you? Minus 60 at Venus still. So Mercury absorbing more light by the looks of things. Albedo is 12. But Venus is at, where are we? 21. So that's made the difference. So Mercury, the warmest planet in the solar system. That's interesting, isn't it? There he is. Got his nice magnetic field as well for that protection. So if we just go inside the magnetic field here. Now, does it contain 93 Earths? Look at that. There you go. So does it still have the water that we gave it when it formed? It does. So if I just go ahead and give it the customization. It's a surface. Let's give it what it wants. So, sea level. We're going to increase it. Just so we can actually see. There you go. So the water is on the surface of the young Mercury. Look at the young Mercury. Check that out. It's looking good. Vegetation. Is it going to have anything? The game doesn't think it's habitable yet. Wonder why. Maybe the atmosphere pressure. What is the pressure? It's not a level. Yeah, look, the pressure's too low for any life. That's why it's not giving it to us. Maybe that will warm up. Now it's getting a... it does contain carbon dioxide, doesn't it? Where is it? So hopefully that'll build it a better atmosphere. But Mercury, the young Mercury, it's got its liquid oceans. Let's see how it does. It doesn't have the surface pressure for a real good conditions yet. Venus, minus 60. Earth. The young Earth is frozen at the moment. Not enough luminosity yet. But it does have its normal atmosphere. Venus, here we go. Rotating a lot faster than normal. Looking very good, isn't it? Still has its thick clouds though. Underneath, that's it, what it looks like. That mix of textures. Venus again, so far, looking pretty strong. Hopefully it will get a nice nice position at some point. But Venus no longer has the water that we gave it. So what happened? So a world that, it's got the magnetic field, it's got the size, but it doesn't have the composition in this scenario. For some reason it was lost. We're not going to add it back. We're locked in now. I'm not altering any compositions. I'm allowed to add the sea level because that's just making it so it's visible. I'm not adding any more material to any of these. So Venus, for some reason, I'm sure we gave it to it, but it's lost it. I'm sure we gave Venus a lot of things actually, but it hasn't retained it. Unless it was me messing with the atmosphere earlier, but I don't think that should have changed the composition. So Venus. It's just a world that's just going to sit. It hasn't got any greenhouse gases. It's got a bit of nitrogen. It's got a nitrogen atmosphere. Other than that, Venus it is what it is. So it's just going to be a world of an atmosphere, but not much going on it. That's interesting. Earth, again, just needs the warmth underneath it. Just needs the warmth. Other than that, it's pretty much good to go. It's got its normal composition. That hasn't been altered in any way. No life flow. It's too cold. But it has got all it needs. What's the Theia? It's kind of an orbital resonance of Earth at the moment, on opposite ends of the sun. So here is Theia. Again, it's got its protection. Can we customise it yet? Is it going to let us? Oh, it can. It is. Or is it? No. So Theia's texture's a bit messed up. That's its map, but we're not going to have the Mars map. I mean, technically, I can just change the map. Actually, give it a bit of action. So we'll just change the map to something else. Give it anything. Got Mimus, Tiffies. What should we give it? Ooh, yeah. Oh yeah, I forgot these existed. They're pretty cool. Yeah, but they're not so realistic looking. Yeah, that's very funky. Get the Ganymede look. We'll just give it a texture that we wouldn't normally use, like Demos or something like that. Phobos. I'll go with that one. Atmosphere on it, we can give it a bit of customization so it's not identical to Mars, I guess. There you go. Bit of ray light scattering as well. There you go. So the young Phaeya. There you go. That's Phaeya, everybody. There you go. Give it a different trail colour to Mars as well. There you go. Cool. Mercury. So far, the best looking world in here. We're going to give that a nice pale blue. Venus. It almost looks green in appearance. We'll get a bit more of a... There you go. So a very interesting lineup we have here. Mars, again, this is a world that just needs temperature. I mean, we can give it some sea level for now, but it's just going to freeze. But we can give it there. So it's there in the future, because it does have the material. There it is. So that will obviously freeze up. But yeah, the young Mars, looking good. It's got its a magnetic field. It's got its composition. So that Mars will just freeze. Again, Ceres, how are we doing over here? This is a full-size planet, remember. Let's have a look underneath. There it is. Now, how's its composition doing? It lost its water as well. Look at that. It did have water, but it's lost it. I mean, I can give it a sea level, but I don't know what liquid it will be. Yeah, it's not got anything that will give it a sea level. Oh, that's a shame. So Ceres, a world that had the promise, but I guess all that water's been converted somehow. It's gone. But we still have some good candidates in here. We've got the Earth, Mercury, and Mars. We've got 3 potential life worlds here. Mercury just needs that atmosphere to give it all it needs. Let's check its atmosphere. Look, it's building an atmosphere though. Look at that. So that will hopefully... Look at it build up. There you go. Let's see how it does. Let's start evolving this system a bit. Oh yeah. It's getting a bit of... Ooh. Is it too much for Mercury to handle? 12 ATM. Ooh, maybe it's that, you know, it's that composition. A bit of everything's mixed in there, isn't it? How is it doing? Let's see the stat. 0. It's got the temperature. That ATM may be a little too violent for it. The old Mercury. How is it doing? Where's our sea level gone? Has it just removed it? Or is it... Oh, no, it is there. Yeah, okay. Ooh. Yeah, so again, I'm allowed to touch the sea level stat, just not anything else with the composition. I'm not allowed to alter this. Oh, there you go. So it just needed a little reconfigure of it, but there you go. So Mercury right now is the most habitable world in the system. So if we slow things down, have a better look at it. Yeah, sometimes the sea level has its mind of its own, doesn't it? So now it's 2-filled. But again, that can have an effect on the stat. There you go. So maybe Mercury's just very ocean rich at the moment. Let's put the vegetation on. And yeah, the game gives it the habitable vegetation. Green. There you go. Look at that. Mercury. Most habitable world in the system. Who would have thought? There we go. All we did was give it the composition, but I think that is going to hurt its average. Yeah, the water. Ooh, it's very warm, isn't it? But at the moment, it is in a good position. I don't know how long that will last. That atmosphere pressure is a bit much. It's kind of had the Venus effect. Just being a little too close to the sun to really have it. Oh, that's changed. I didn't touch that. I just touched the sea level. So the atmosphere just reconfigured to the sea level a bit. Interesting. Very, very interesting. So, for instance, if I was to lower the sea level, then would that revamp it a bit? Let's just halve that. Or give it, you know, something just so it's not flooding the whole thing. How's that up here? Well, the sea level is a very bizarre gauge sometimes. There we go. Yeah, it does reconfigure it. Okay, so the sea level does jank the atmosphere, but the game likes to reconfigure the atmosphere based on the sea level, so we have a bit of control over that, just to make it see how it looks. So the habitability's gone. Look, it's gone back to the grey texture. Bizarre. Very bizarre. If you look at the lifestyle, I'm guessing that's going to be janked up as well. It's increased on its own, though, so there you go. But the sea level, we only do that for the visuals, but yeah, it seems to affect the gauge a bit, doesn't it? There you go. But again, Mercury. Potentially the best place to be at the moment. Very, very nice. Okay, that's good stuff. But for now, we've got our system built. There's already been some changes, but we're going to end off today's episode there because I've just noticed how long we've been going for. I don't want to make this episode too long. So with that all said and done, everybody, I hope you've all enjoyed this part 1 of our version 2 alternate reality solar system. Let me know what you think so far. How do you think it's gone? Is there anything I should have done differently as well? Let me know down below in the comments. But I'll be keen to see your thoughts and opinions on this one. I think we've got quite a good lineup so far, and it looks like the system, for the most part, could retain quite stable. That dominant Neptune, maybe it hasn't got as much power as we thought. It's further out. It's still an ice giant, but maybe, you know, it's not in the position to really wreck the inner solar system. There's no Jupiter and Saturn orbit or presence to really pull a lot of things around. So maybe the inner system will stay in a very good position. It's just that Earth, Theia, Mercury, Venus, they're very similar positions. So that could definitely cause some turmoil in the future. But stay tuned for the future. I'll have that coming out next week for everyone. But with that all said and done, everyone, let's see if we can hit that like button. Let's go for 100 likes. Subscribe for more, help us on journey to 50,000 subscribers as well. Support means the world. Really, really appreciate it. But with that all said and done, everyone, make sure you have a great day. Stay safe out there. And I'll see you in the next video. Goodbye.